Okay, welcome back. Today's lesson, and we're gonna do the composite functions. First thing first, we need to know what is the composite functions. And the new functions h is set to be the composition of the g and I with f. So we can write as h equal to g and dot f. So of f. So composition of f functions followed by g. And root is can be rewrite as hx become to gfx, which is you're gonna substitution the fx into the gx function. So in general, we know range gonna belong to the domain of g. Range function function of x is belong to the function g of the domain. We define the composite function of the g with f by gfx. So then your domain of G and followed by F is gonna be domain function. And then we know the domain of function of X is actually belonging to the domain of the G and range of the F. And then we come back to the GFX. It's kind of like a very complicated the graph, but that's okay. Once we do the questions, I will show you. We make a tables and make them clear. Okay, question example 1. So we know fx is 2x minus 1, gx equal to 3x squared. So we could do is, we're gonna start with some domain range each other. So we're gonna recreate the tables. Okay, so function of g, function of f, and domain and range. Okay, so because it's Christmas nearly there, and then we're gonna start some colorful, beautiful red and green colors to make like the Christmas tree looks like good. Then domain for gx is real number. And function of domain is real number as well. But range is a little bit different. Range for the gx, actually, we can say, if we graph it, that looks like, yeah, pretty much. It's a positive and also including a 0, so which is we could write 0 to positive infinity. But function of x, the range will be the real number. So we can say we need to do with f and followed by g and g followed by f the both. So first thing first, we could write as f g equal to f and gx. And as we know, which is we're going to substitution the gx into the fx, so that become to 2x minus 1 and change to fgx equal to 3x squared minus 1. And then that actually equal to 2 times 9x squared minus 1. So that equal to, 2 times, my mistake. So 2 times 3 x squared. So that equal to 6x squared minus 1. So you have to substitution the gx only into the x. Okay, it's not squared. And it turns out, we can say 6x squared minus 1 for domain equal to the real number. And range actually equal to from -1 to positive infinity. Perfect. Does that make sense? Because if you drop the 6x squared minus 1, that actually equal to minus 1 to positive infinity. All right, and then we're going to do the another way, which is function of g of fx. And we can say 3 and 2x minus 1 squared. And that actually equal to 12x squared minus 12x and plus 3. And turns out your domain become to the real number, which is equal to the domain of function f. And range equal to 0 to positive infinity, which is that's exactly of the g of the x. Perfect. Hopefully that makes sense. And I will show you how we're doing the TI and Spreadcast during the class as well. All right, example 2. I only need to do one. Hopefully you can start creating your own as well. So that will be pretty similar. So we know range of function of x is belong to domain of g. So first thing first, create a table. No matter what, draw the table, you will get a mark. So f and g, domain and range. Okay, perfect. Now, let's start with g. G actually, the domain range actually equal to or real number. Actually, not really. Fx is the square root of x, gonna be positive real number. And also including 0 as well. Including. So real number including 0. And real number for the both for gx. And then state which is the f followed by g and g followed by f. But the only question they want to ask about to answer the composite function is defined state the domain and rule. So which is we could do g f, which is g f x is defined. But let's have a look. Because your domain and range are different, your function followed by gx is not going to be defined because it's never going to have a negative number. So not defined. And you could put in the case to find out which one going to be preferred. So in question B, we could write as g f x equal to g f x equal to 2 square root of x minus 1. And turns out your domain equal to the positive real number includes the 0. Perfect. And that's it. That's for today.